Welcome back to Designing AI-Driven Personalized Learning Environments course. In this video, we'll talk about learner modeling using IRT, Item Response Theory. Item Response Theory is very important key approach in a psychology. It is used been many decades, I think 4 or 5 decades now. In a psychometric test, I think they are using the Item Response Theory to understand the question difficulty is correct, the question is ability to measure the given audience is correct or wrong, and arranging in order, all those things. Item response theory has been used. Item response theory is actually very long topic. There can be separate course on item response theory with the multiple variables, but for this particular video we'll see only single variable item response theory. And this item response theory has been used in this assessments like GRE, CAT exams, not in the CAT, I'm not sure, but in the GRE definitely. If the student answers the question correctly, the next question will be more difficult. If the student answers more difficult question, not able to answer, next question can be easier question. So arranging the adaptive of the questions is done by the item response theory. It's GRE, TOEFL exams, and it's also used in modeling learners in ITS. So we'll talk about one of the paper which used item response theory to model learners in ITS and how it uses to provide personalized content, how it used to understand the learner's skill and matches the ability, matches the proper content. So this video will be a bit longer. I want everyone to focus on it and take a pen and notebook and need to do some mathematics. So please focus on this video. Kind of question in the sports, if I want to find out how high you can jump, for example, in the sense I have 30 students in my classroom, I want to find out for each student how high they can jump, how high should I set a bar to start with. Okay, think about it. It's a very interesting problem. There are 10 students or 30 students. I want to know for each student what is the maximum height they can jump, so I can set a bar. Okay, I hope you thought about it. So what you would do, you have this height of the bar is the item difficulty. Okay, height of the bar difficulty, and your optimal height is your ability to match is the theta. For example, the height of bar is 3 meters. Your ability is 2.8 meter. Okay, so to find out what I would do, I would start with a very low height, say 2 meter. You do well, and I increase to 2.2. You do well, 2.4. So when I keep on increasing, still you have struggle, then I will reduce it where you are able to jump without having any struggle. So I will find the optimal, optimal height of each learner. So the height is the difficulty level of the question. The ability you can do is the theta, that is your ability to jump it. So the idea is that we need to match the height of this bar with the student's ability, that is the student's learner ability with the question difficulty. How can I match the question's difficulty level with the student's ability? That comes with the zone of proximal development. I think we talked about ZPD in a couple of videos ago. What is ZPD or zone of proximal development? Is this particular circle is what learner can do without any help. So this is your current knowledge about any concepts. I can add, I can read a book, I can do something, I can create some small electronic kit, I can solve set of sums, I can program or create a small website. This is what I can do. There are set of things a learner cannot do now. In the sense, learner cannot create a complete set of systems to run automatically without human help, some robot, all these things we don't know. There are set of things learner cannot do. For example, for 4th standard students, you are asking them to do a calculus, definitely learner cannot do. Okay, but in between, from the learner's existing knowledge to the learner cannot do, in the mathematics, there are some of the knowledge learner can do with help of experts in the field. They are able to understand a bit. For example, they are able to do some bit of algebra. They won't understand set of limit theorems. So I could teach them a first standard students about variables. So learner can do with experts some experts. It's called zone of proximal development. We want to push the learner from this particular part to this part slowly, then this part. When the learner is in this, the zone of learner can do without become that zone, then learner which cannot do might become the zone of proximal developments. This theory has been developed by Vygotsky. There he talks about the expert is actually the expert in the field who comes and talks to a small kid about astronomy, and with the help of that expert, the student, the 4th standard 10-year-old kid would understand better than what he can know already, that kind of knowledge. But in general, what we are trying to do is that instead of this expert's knowledge, a learner can do something on its own. If I push the learner to do an extra next step and I can provide a guidance, the guidance is provided by scaffolding, providing proper hint, providing more remedial content by proper scaffolding, a student can able to that zone of proximal development. Then we could move on to the next step. That is the idea. Here we need to understand the learner's ability, that is the theta, and we need to match the difficulty level here. Okay, how I do it here. So the first step is, instead of going to zone of proximal development, how can we match theta and b? How do you measure this theta? How do you measure this difficulty level? That's the question in this lecture. So how do you measure the difficulty level of the question? Very simple. We could the experts can define, the experts can define their own difficulty level, or you could ask the students, is the question difficult, high or low or medium? We collect that information, then we can use that as a difficulty level. How do you measure the learner ability? That we'll see in this video. So this paper in 2005, it's personalized e-learning system using item response theory in Computer Education Journal, published, and is also the seminal paper in the field in the intelligent tutoring systems. Here the idea is that don't go into the system, don't go worry about it, the system is not cutting all the data. It is in 2005, 20 years ago, 22 years ago. So consider this, a system is simply asking the student set of concepts, okay, a course material is provided, okay, and after being the assigned material, student is asking two questions. One, what do you think about the difficulty of this course material? The student can say very hard, moderate, easy, or very easy. You see the Likert scale, hard is 2, so very hard is 2, hard is 1, 0, -1, -2. That's a Likert scale. Another set of questions asked, do you understand the content of the course material? The student can respond yes or no. Here there is no question a student is answering, we are trying to answer the student's response is the right. If student understood the course material, which means students knows the topic, we are not testing it, okay. Hope it is clear. So it is for here, I think for this one particular paper, don't assume that's always the case, I'm just giving you the example here. What do you think of the difficulty of this course material? They would add in the Likert scale, they can choose one of this. What do you understand the concept? They say yes or no. These two concepts, be it clear. You can read this paper, it's a very fantastic paper which actually explains the ITS schematic diagram with arrow marks showing first step, second step, so complete path of ITS has been explained. That's the kind of way we used to learn, but now that's all changed, that's nobody likes those tracing paths. But yeah, if you're interested in those kind of papers, go and read this paper, it's a very interesting paper. So let's see how to use these two data to first identify the difficulty of questions, second to identify learner ability. So the difficulty level is kind of assumed based on the average voting. Suppose a student is doing a 2, 1, 0, -1 and -2. Based on that, we are able to we're able to measure the average voting. Suppose a number of students answered a set of topic is really high difficult, their question will be marked as high difficult. I'll see this in bit detail. So initially, as an expert, I would have this knowledge saying that hey, this particular topic is easy or very easy or the medium, okay. So I would assign -1 or 0 or hard topic or 1 or 2. Based on the students voting, we could change it with the weighted value. One, the weight can be, if you want to give a more emphasis on the expert, give a W to be more, say 0.8 or 0.9. If you want to give more emphasis on the learner, that is the voting, give it the more weight, less weightage to the W. But beware that if you are adaptively changing this difficulty level of the thing, a set of learner can come and dynamically change the difficulty level. So do you want to consider all this weight to be more on the expert or the learner? You have to make a decision. My suggestion is always go for the expert is more weighted. Change it, delta change can be done very little based on the number of learners doing it. So this is the formula. We'll look at this formula in detail. So I am trying to give you the formula here. Is that the tuned value is the initial weight, initial difficulty level, which whatever you consider 2 or 1 or no, and voting value is based on the learners voting. If there are 10 learners, learner 1, learner 2, learner 3, this is learner 1 to 10 learners, the item, the learners rating item 1 is the topic 1 as a 2. For example, he said this particular question is very hard. Item 2, the learner says easy, but learner 2 says item 1 is hard, medium, very hard, hard, very easy, easy, or medium, or very hard. So what would be the BJ voting, like the difficulty level of voting of this particular item? That will be right. There are 5 scales. Don't worry about this formula. This formula is to make it standardized. For 1, how many people have said 1? So okay, let's go for 1. For Nij, how many people have said 1? One of these, maybe I could say, how many people have said 2? 1, 2, 3. 3 people out of 10 learners marked the difficulty level of 2. This is the value. So then I could compute it and count it, or you could do simple action. This formula is kind of confusing, but the very simple basic formula is that add everything and divide by 10. That average would give the answer. So 2 plus 1, 3, 3 plus 2, compute it. I want you to compute the difficulty level of both items, item 1 and item 2. Consider the initial value is 1 for both items and the W is 0.8. I want you to pause the video, compute this difficulty level of these questions. I hope you did it. We just go through that. The Nij is 2. 2 learners as marked -2. 2 learners has marked -2. Then 1 learner marked -1. 2 learner marked 0. 2 learner marked 1. 3 learners marked 2. So if you sum it, the point, or if you would have done the same, 3, 5, 6, 8, 8 minus 5, 3, 3 by 10, 0.3. I think this will get it. This is just to standardize it in a large scale, write a program. This is programmatic way. So they would have got the BJ voting for the first will be like 0.3. Then if you would have substituted 1 into 0.8 plus 0.2 into 0.3, you would get the answer. That's kind of 0.86. Here the point is that the initially learners, initially the experts decided this particular item is difficult. The item is very difficult, in the sense hard, but the most learner assumed it is 0.3, which means not really hard, very medium level topic. Should I change it completely to my change the initial difficulty of 1 to the 0? That depending on the weight of this. Now I'm just reducing 1 to 0.86. I'm reducing the bit. So if more and more learners says it's not difficult, I would change slowly to the learner's difficulty level. That's the idea. So I give more emphasis on the expert here. Okay. I hope it is clear now, like how to identify the difficulty level. The difficulty level is actually identified by getting the user's responses votes, and with the expert knowledge, it's combined and data. Very simple maths. Okay. Now let's go to the how do we identify the learner ability. I'm not going very deep into the maths. Instead, I'm trying to give you the idea what's that happening. So before we jump into this, I just used Wolfram alpha to show that. So you know that e power e power 0 is equal to 1, and if I do this e power 0 divided by 1 plus e power 0, it will be 1 by 1 plus 1, 1 by 2 will be 0.5. So for 0, this will be 0.5, correct? When I increase the e value into 1, 2, 3, minus 1, minus 2, it will have different values. Actually, the curve will look, I think it looks like this. It will never reach the 0 here, it will never reach the 1 here, till the end. So I think most of you know this is the sigmoid curve or logist equation logit function. It's the one of the most important and most useful function in the ML methods. So if you know, it's fine, but don't worry about that. It's just the idea that how the exponential PG of theta has been computed. This idea is enough for to go to next slide. To understand the learner ability, we are going to use maximum likelihood probability. Okay, what is ML, maximum likelihood? So in this particular thing, what you are going to do, we are going to compute the learner ability, say theta. We don't know the learner's theta as of now. Consider initially the learner's theta is say 0 or 1 or minus 1 or some value theta. So learner's response to the item, the learner have a different 4 items. Okay, item 1, item 2, item 3, item 4. Learner responds to the item 1 whether he understood the item or not. He said no, I don't understand. He said yes, yes, no. Okay, this is learner's response to the each item. We already computed the difficulty level of the each item after all the responses from the students. Item 1 is kind of hard, this is medium hard, very hard. Okay, this is the table we have. Can we use this table to measure the learner's ability? The learner said yes for the medium and one hard question. Learner said no for the one hard and one very hard topic. With this knowledge, can we measure the learner's ability? Learner's ability can be again measured in terms of minus 2 to plus 2. This is a key theta. Okay. Learner's ability is again measured using minus 2 to plus 2. Okay. Minus 2 indicates the poor performer. My plus 2 indicates the best performer. Again, another Likert scale kind of idea. How we are going to measure the learner ability given this score? So we have given a learner some 4 topics. Learner responded 0 or 1 or 1 or something. The BJ tuned is first the previous learners, not this particular learner. The learner comes up with the learner's own ability, then started doing 0, 1, 1. I need to measure the learner ability after they say these 4 responses. So in a likelihood probability, what we do, we want to do the probability of learner able to answer this particular question correctly, plus the Q is the reverse inverse probability whether the student is not able to do it. It's very simple that way. We want to do product of, for each item, what will be the most highest probability. A learner will say yes for this particular topic, and we need to measure it. So Pj theta is measured using e power that value. So here theta will be the learner theta will be, we don't know value. We can start with the minus 2, and we can minus 2 minus bj equal to 1. So minus 2 minus 1, maybe say minus 3, then 1 plus 1 minus 3, you can compute it and you see what answers comes. So the idea for you is that you could pause the video, try to compute this particular thing. I want you to assume the learner value is that the theta can be from -2 to 2. I want to assume first the one particular theta, say -2. Assume -2 here, then compute the learner's difficulty level for the all the topic 1, topic 2, topic 4. Compute the Qij. Then I wanted you to go it over all the 4 topics and find out the product of all these things. Then go with the theta equal to -1, repeat the problem, go with the theta equal to 0, theta equal to 1 and theta equal to 2. Then find out which particular theta has the maximum likelihood probability, more probability is coming, that is what I want to compute. So if you understood this mathematical problem, pause this video and try to solve this. We'll go in detail because if you need help, we got to solve this particular problem here. Given the theta equal to 1, consider the theta equal to 1, compute pi pj theta, the probability that the user will answer yes to this item. So what we do for item 1, this is the item 1, okay, the bj tuned is 1, correct. So what we do, we will first find out pj of theta, that is, how do I do, e power the theta equal to 1 minus 1 e power 0 divided by e power 0, e power 0 divided by 1 plus, that will be like, that will be e power 0 divided by e power 0 plus 1 will be 1 divided by 1 plus 1, 1 by 2 will be 0.5. For item 2 the value is 0, so theta is still 1 now, 1 minus 0, so e power 1 divided by 1 plus e power 1, the value will be 0.73. For item 3, since it is same, it will be 0.5. For item 4, this is 2, so it will be -1, e power -1, e power -1 and 1 plus e power 1, so 0.26. Okay. Now you have 4 items computed. With this you could also compute the Qj of theta, that is just opposite, 0.5, 0.27 and point something, we can compute it. With this, can I find this L value? Let's say for the theta equal to 1, for theta equal to 1, compute these values, all those values we computed, item 1 to 4, item 1 to 4, compute all these values and compute all these values and find the L value. L value will be 0.3. I want you to compute it. I hope it's easy to compute. If I have compute multiple thetas, 1, 0, 2, -1, -2, say, you will have a likelihood probability, and which is the maximum likelihood probability, will take it. So we will say the theta 2 as the maximum likelihood probability. I would consider the learner ability is like but good performer, although the student has answered answered a couple, the hard question is not possible, but it's considered to be the good one. So that's the idea. So I hope you can do that. So to want some more detail, I'm actually giving more detailed response how this computed 0.13. So I hope it is clear. In item response theory, we compute the difficulty of questions based on the learner's voting. Second, we try to compute the learner's ability based on their response to the items and the item's difficulty. We consider that and we try to do it. So that's the idea of how to compute the maximum likelihood and measure the students' learner ability. Now, once we know the learner ability, we could definitely match their learner ability with the proper content. If the learner ability is 2, I will give the more very hard content to the learner. Then I compute again, if the learner's feeling is not correct, learner is failing again, I would compute the learner ability again in next item. I will match the next content. So that's how the item response theory works. That is how the exams, competitive exams like a GRE, TOEFL exams conduct a test. So I want to ask, I think now since we talked about item response theory, and we saw domain model in the previous week. What is a domain model in the personalized learning system using IRT? Just pause the video. You know what is domain model, right? What is domain model in this? Pause the video, think about a minute and write down the answer. The learning items are domain model in the IRT. Also, identifying difficulty of the learning item and updated value of each domain is part of the domain item. Each items and its difficulty item is part of domain model. The theta we computed is the only learner model in the IRT. The idea is to compute the theta using their response and the item difficulty. So learner's ability, response to each item, the password, everything if it needed, that's all the learner model. Those are two things you have to understand. Domain model is fixed. For example, each item have the fixed item difficulty level. But this learner model kind of adapts, changes based on the learner's ability. Thank you. Thank you for watching the item response series. This is one of the bit tricky video, but I hope you understood how the learner's ability and the item difficulty is computed in the IRT systems. I would recommend you to check the paper and read it once. It's a very interesting paper.